Hey everyone, welcome back to Instrumentation lectures. So in the previous videos, we had introduced ourselves to errors in measurement and also classification of errors. In this lecture, we will see how to do basic mathematical operations like addition, subtraction, multiplication or division when errors are present. This is very important because if we do an experiment involving several measurements, we must know how the errors in all the measurements combine. So let's start our lecture. While doing calculations with errors, you have to follow just two rules. First is, when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Second rule is, when two quantities are multiplied or divided, the relative error in the final result is the sum of the relative errors in the multipliers. Okay, so once you know these two rules, you can do any calculations with errors. Now let's see how we arrived at these rules. First, take the errors in addition. Suppose two physical quantities A and B have measured values A plus or minus delta A and B plus or minus delta B respectively. Note that delta A and delta B are the absolute errors in A and B respectively. Now we wish to find the error in the sum Z equal to A plus B. We have by addition Z plus or minus delta Z is equal to A plus or minus delta A plus B plus or minus delta B, which can be written as A plus B plus or minus delta A plus delta B, and just now we have seen that A plus B is equal to Z. So we can write this as Z plus or minus delta A plus delta B, and this is equal to Z plus or minus delta Z. We can cancel out these Z's, which leaves us with plus or minus delta Z is equal to plus or minus delta A plus delta B, or delta Z is equal to delta A plus delta B. Therefore we can say maximum absolute error in Z is equal to maximum absolute error in A plus maximum absolute error in B. Similarly, when we take the case of subtraction, suppose we need to find the error delta Z in the subtraction A minus B, we have Z plus or minus delta Z is equal to A plus or minus delta A minus B plus or minus delta B, and this is equal to A minus B plus or minus delta A plus delta B. And why did we take plus over here? Because we need to add the errors. That is, we always need to write the maximum possible error. We do this because always an overestimate of error is better than an underestimate, right? So Z plus or minus delta Z is equal to, and A minus B is equal to Z. So Z plus or minus delta A plus delta B, and cancelling Z's leaves us with plus or minus delta Z is equal to plus or minus delta A plus delta B, or delta Z is equal to delta A plus delta B. Also note that this delta A and delta B are the absolute errors in A and B respectively. So again from this equation we can say maximum absolute error in Z is equal to maximum absolute error in A plus maximum absolute error in B. Okay, now let's see some example to make the concept more clear. Three resistors have the following ratings. R1 is equal to 37 plus or minus 5% ohm, R2 is equal to 75 plus or minus 5% ohm, and R3 is equal to 50 plus or minus 5% ohm. Determine the magnitude and the limiting error in ohm and in percentage of the resistance of these resistances connected in series. Okay, so the resistances are connected in series. So we have the case of addition, and our rule was when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Here the errors are given in percentage. So first we need to convert them into absolute error formats. So R1 is equal to 37 plus or minus 5% ohm, which is equal to 37 plus or minus 5 by 100 into 37, which is equal to 37 plus or minus 1.85 ohm. Similarly, R2 is equal to 75 plus or minus 5% ohm, which is equal to 75 plus or minus 5 by 100 into 75, which is equal to 75 plus or minus 3.75 ohm. Similarly, we have R3. R3 is equal to 50 plus or minus 5% ohm, which is 50 plus or minus 5 by 100 into 50, which is equal to 50 plus or minus 2.5 ohm. So here the 1.85, 3.75 and 2.5 are all in absolute error formats. Now R1, R2 and R3 are connected in series. So total resistance R is equal to R1 plus R2 plus R3, which is 37 plus or minus 1.85 plus 75 plus or minus 3.75 plus 50 plus or minus 2.5, which is 37 plus 75 plus 50 plus or minus 1.85 plus 3.75 plus 2.5, which is equal to 162 plus or minus 8.1 ohm. Here this 162 ohm is the magnitude of resistance and 8.1 ohm is the limiting error. Also, it is asked to express the limiting error in percentage. Therefore, percentage limiting error is equal to plus or minus 8.1 by true value, which is 162 ohm, into 100, which is plus or minus 5%. And this is relative limiting error. Okay, now let's see one more example. The temperature of two bodies measured by a thermometer are T1 is equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius and T2 is equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Calculate the temperature difference and the error therein. Okay, here the errors are already given as absolute errors, so we can directly calculate the temperature differences. T is equal to T2 minus T1, which is 50 plus or minus 0.5 minus 20 plus or minus 0.5, which is 50 minus 20 plus or minus 0.5 plus 0.5, which is 30 plus or minus 1 degree Celsius. Now let's see the case of multiplication of errors. As always, the measured value of A is A plus or minus delta A, and the measured value of B is B plus or minus delta B. However, this delta A and delta B are the relative errors of A and B respectively. Always remember this. Okay. Now our objective is to find the error delta Z in the product Z equal to A into B. So we have Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B, which is AB plus or minus B delta A plus or minus A delta B plus or minus delta A delta B. Here AB is equal to Z, so we can write it as Z plus or minus B delta A plus or minus A delta B plus or minus delta A delta B, and this is equal to Z plus or minus delta Z. So we can cancel out these Z's, which leaves us with plus or minus delta Z is equal to plus or minus B delta A plus or minus A delta B plus or minus delta A delta B. And if we write this as equation number 1 and this as equation number 2, dividing equation 2 by equation 1 gives us plus or minus delta Z by Z is equal to plus or minus B delta A by AB plus or minus A delta B by AB plus or minus delta A delta B by AB. Here we can neglect this term because the value of delta A into delta B is almost equal to 0, and also we can cancel out these B and these A's. This gives us plus or minus delta Z by Z is equal to plus or minus delta A by A plus or minus delta B by B, or delta Z by Z is equal to delta A by A plus delta B by B. Note that delta Z by Z, delta A by A and delta B by B are called the relative errors in Z, A and B respectively. Also, multiplying each term by 100 gives us percentage delta Z by Z is equal to percentage delta A by A plus percentage delta B by B. Hence, maximum relative error in Z is equal to maximum relative error in A plus maximum relative error in B. Thus, maximum percentage error in Z is equal to maximum percentage error in A plus maximum percentage error in B. Now let's see the case of division. Here also, the measured value of A is A plus or minus delta A, and the measured value of B is B plus or minus delta B, where delta A and delta B are the relative errors of A and B respectively. Now our aim is to find the error delta Z in the division Z equal to A by B. So we have Z plus or minus delta Z is equal to A plus or minus delta A by B plus or minus delta B, which is equal to A plus or minus delta A into B plus or minus delta B raised to minus 1. Now this can be written as A 1 plus or minus delta A by A into B raised to minus 1 into 1 plus or minus delta B by B raised to minus 1. Now the part 1 plus or minus delta B by B, that is 1 plus or minus delta B by B raised to minus 1. Also note that delta B by B is less than 1. So using binomial expansion we can write this as 1 minus or plus delta B by B plus or minus delta B by B square minus or plus delta B by B cube and so on. Here the higher order terms, that is these terms, can be neglected as they are almost equal to 0. So 1 plus or minus delta B by B raised to minus 1 can be written as 1 minus or plus delta B by B. Plugging this into this equation gives us Z plus or minus delta Z equal to A, and there is a B raised to minus 1, so I can write it as by B into 1 plus or minus delta A by A into 1 minus or plus delta B by B, and this can be expanded as A by B into 1 minus or plus delta B by B plus or minus delta A by A minus or plus delta A into delta B by AB. And we can neglect this term a delta A into delta B by AB as the value of this is almost equal to 0. And A by B is equal to Z, so Z into 1 minus or plus delta B by B plus or minus delta A by A and is equal to Z plus or minus delta Z. Now if we divide both sides by Z, we have Z plus or minus delta Z by Z equal to 1 minus or plus delta B by B plus or minus delta A by A, and this is equal to 1 plus or minus delta Z by Z equal to 1 minus or plus delta B by B plus or minus delta A by A. Cancelling out these ones, we can write plus or minus delta Z by Z equal to plus or minus delta A by A minus or plus delta B by B, or simply delta Z by Z equal to delta A by A plus delta B by B. Note that delta Z by Z, delta A by A and delta B by B are the relative errors in the values Z, A and B respectively. Also if we multiply each of these terms by 100, we get percentage delta Z by Z equal to percentage delta A by A plus percentage delta B by B. Hence, the maximum relative error in Z is equal to maximum relative error in A plus maximum relative error in B, or maximum percentage error in Z is equal to maximum percentage error in A plus maximum percentage error in B. Now let's see two examples related to multiplication and division of errors. The first question is, the resistance R equal to V by I, where V is equal to 100 plus or minus 5 volt and I is equal to 10 plus or minus 0.2 ampere. Find the percentage error in R. Okay, so this is a case of division. Remember that when two quantities are multiplied or divided, the relative error in the final result is the sum of the relative errors in the multipliers. So first let us express the errors in percentage. We have V is equal to 100 plus or minus 5 volts, which is 100 plus or minus 5 by 100 into 100, which is 100 plus or minus 5% volts. Similarly, I is equal to 10 plus or minus 0.2 ampere, which is equal to 10 plus or minus 0.2 by 10 into 100, which is equal to 10 plus or minus 2% ampere. Now the magnitude of resistance R is equal to V by I, which is 100 by 10 or 10 ohm, and percentage error in resistance is equal to percentage delta R by R is equal to percentage delta V by V plus percentage delta I by I, which is 5% plus 2% is equal to 7%. Therefore, resistance is equal to 10 plus or minus 7% ohm, which is equal to 10 plus or minus 7 by 100 into 10, which is 10 plus or minus 0.7 ohm. Okay, let us see one more example. The power P equal to V into I, where V is equal to 230 plus or minus 10 volt and I is equal to 100 plus or minus 5 ampere. Find power. Okay, so first we will convert the errors into percentage error. Therefore, V is equal to 230 plus or minus 10 volt is equal to 230 plus or minus 10 by 230 into 100, which is 230 plus or minus 4.348 percentage volt. And similarly, I is equal to 100 plus or minus 5 ampere, which is equal to 100 plus or minus 5 by 100 into 100, which is 100 plus or minus 5% ampere. Now the power P is given by V into I, which is 230 into 100 plus or minus 4.348 percentage plus 5%, which is 23,000 plus or minus 9.348 percentage watts, which is 23,000 plus or minus 9.348 by 100 into 23,000, which is 23,000 plus or minus 2150.04 watts, which is approximately equal to 23 plus or minus 2.15 kilowatt. Okay, now let us see how the errors propagate in the case of product of powers of observed quantities. Suppose Z is equal to A square and the measured value of A is A plus or minus delta A. So we have Z plus or minus delta Z is equal to A plus or minus delta A square. But note that A square can be written as A into A. Therefore, this is A plus or minus delta A into A plus or minus delta A. So we can see that the case of powers is basically repeated multiplication only. Therefore, delta z by z can be written as delta a by a plus delta a by a, or 2 times delta a by a in this case. Or if we express the errors in percentage, we have percentage delta z by z is equal to 2 times percentage delta a by a. Hence, the relative error in a square is 2 times the relative error in a. In general, if z is equal to a raised to p, b raised to q and c raised to r, then the relative errors can be expressed as delta z by z equal to p times delta a by a plus q times delta b by b plus r times delta c by c. Hence, as a rule, we can write the relative error in a physical quantity raised to the power k is k times the relative error in the individual quantity. Let us also see an example. The period of oscillation of a simple pendulum is t equal to 2 pi root of L by G. The measured value of L is 20 cm, known to 1 mm accuracy. Therefore, we can write L is equal to 20 plus or minus 0.1 centimeter, because the accuracy is 1 mm and 1 mm is 0.1 centimeter. And time for 100 oscillations of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. Therefore, the time t can be written as 90 plus or minus 1 seconds, because the resolution of wristwatch is 1 seconds. Okay, so what is the accuracy in the determination of G? Now, using this equation we can write G is equal to 4 pi square into L by t square, and this time period t can be written as time taken for n oscillations by n oscillations. In the question, the number of oscillations are 100, therefore by 100, and the time taken for 100 oscillations was 90 seconds, therefore 90, which is equal to 0.9. Also, delta t is equal to delta t by n. Here n is a fixed quantity and is not prone to error, so there is no uncertainty in the case of n. So from these two equations we can write delta t by t is equal to delta t by t. Now to find the error in G, delta G by G is equal to, we can ignore the constants for pi square and we have delta L by L plus 2 times delta T by T, and the uncertainty delta L is 0.1 centimeter, 0.1, and the value of L is 20 plus 2 times delta T is 1 seconds and the value of T is 90 seconds, which is 0.027. If we express it in percentage, we have percentage delta G by G is equal to 2.7 percentage. Okay, so far you have seen how to do combinations of limiting errors. However, there is a slight change when it comes to the case of non-errors. We have already discussed about non-errors in the last video, but I will just say it again here. These are errors that we know the instrument possesses for sure, and we also know the sign of these errors. So, when it comes to calculations with non-errors, we must preserve the sign of errors. Let us see an example so that you get a better idea. Current was measured during a test as 30.4 ampere flowing in a resistor of 0.105 ampere. It was discovered later that the ammeter reading was low by 1.2% and the marked resistance was high by 0.3%. Find the relative error in the power calculated. So, it is specified that the ammeter reading was low by 1.2%. Therefore, percentage delta I by I is equal to minus 1.2 percentage. And similarly, percentage delta R by R is equal to plus 0.3 percentage. Now we know power P is equal to I square R. Therefore, total percentage relative error percentage delta P by P is equal to 2 times percentage delta I by I plus percentage delta R by R, which is equal to 2 times minus 1.2 percentage plus 0.3 percentage, which is equal to minus 0.021 percentage. That's all for this lecture. To summarize, there are two golden rules that you should keep in mind while doing calculation with errors. They are: when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. And when two quantities are multiplied or divided, the relative error in the final result is the sum of the relative errors in the multipliers. If you found the lecture useful, please like the video and also support us by subscribing to the channel. Also, if you have any doubts, feel free to ask them in the comments so that either me or some other viewer can help you. In the next video, we will see some more questions related to combinations of errors. Thanks for watching and have a nice day.